Okay, welcome back, and now we're going to do maximizing time. Okay, so here's another optimization problem involving time. So I'm going to read it to you, then we'll jump right in. It says, an island is 2 miles due north of its closest point along a shoreline. So I drew this picture. So let's say this is the shoreline, and so it says an island is 2 miles due north of its closest point along the straight shoreline. So this here is the island. Okay, so here's the closest point, right? So it's going to be straight across the shoreline. So here's the shoreline. Okay, so this is going to be 2 miles. Okay, now it says a visitor is staying at a cabin on the shore that is 6 miles west of that point. So west of this point. So 6 miles to the cabin. Okay, so here's the cabin. Okay, so this is going to be 6 miles. Oh, let me move that. So this is going to be 6 miles. Okay? Okay. It says the visitor is planning to go from the cabin to the island. Suppose the visitor runs at a rate of 8 miles per hour and swims at a rate of 3 miles per hour. Okay, so let's say the visitor runs. Okay, so runs at what rate? It's going to be a rate of 8 miles per hour. That's pretty fast. And swims 3 miles per hour. Okay. So now, how far should the visitor run before swimming to minimize the time it takes to reach the island? Okay, so here's the gist of it, right? So he's going to run. At some point he has to swim to the island, right? So at some point he can't just run to the island all the way. So somewhere along this path he's got to jump in and start swimming. Okay? Now he could start swimming here and swim directly and do no running. Or he could run all the way here and then swim straight across. Or he could stop anywhere in the middle. So the question is where should he stop, right? So at what point should he stop and start swimming to the island to minimize the amount of time it takes him to get to the island? That's the question. Okay, so what are we trying to do here? What are we optimizing? The amount of time it takes to get to the island. In other words, we're, in this case, minimizing time. Okay? So, now, so we've got to relate time to his running and swimming, right? Well, if we use time, we've got to figure out, we've got to incorporate the rate, right? Okay, and let's incorporate the distance here too. Okay, so the question is let's figure out how we're going to set this up. So let's call this distance here. So the distance he's going to run. Okay, let's call it x. Okay, and then let's call this distance. We'll call this 6 minus x. Okay? And now we've got to find this distance. Let's call it s. Okay? So we've got to figure out how far he's got to run and how far he's got to swim. Okay? So those are the two things we need to consider. Okay? Now S, okay? S is going to be using the Pythagorean theorem here, right? So S is equal to 2 squared, or the square root of, 2 squared plus 6 minus x quantity squared. Okay, so that's going to give us S. Okay. So now we've got to come up with an equation that gives us time, right? So let's say it's the rate he runs is miles per hour, right? So that's going to be 8 miles over hours, and his swims at 3 miles per hour. Okay, so we need time. So if we remember, if we take distance equals rate times time, then we can also say time equals distance divided by the rate. Well, we've got the rates, okay? So the time it takes him to get to the island is going to equal to the time he runs plus the time he swims. So the time he takes him to run is going to be what? It's going to be the distance he runs, which is x, divided by the rate at which he runs, which is 8, plus the distance that he swims, which is s, divided by the rate at which he swims, which is 3. And then, of course, we've got s is equal to this, so now we can substitute in. And so our final formula for t is going to look like this. It's going to be x over 8 plus the square root of 4 plus the quantity 6 minus x squared over 3. Okay, and so now we have a formula that we can solve. Okay? Okay, so now we got to figure out x, the domain of x. Okay, well, he can only run 0 to 6 miles. That's it. So the domain, so we're going to be considering the interval for the distance he's going to run is going to be from 0 to 6 miles. Okay? So now let's simplify this a little further. Okay. Let's make this, so x over 8 plus the square root, this is going to be 4 plus 36 minus 12x plus x squared over 3. And so this is going to then give us what? X over 8 plus the square root, and this is going to be 40. Well, let me write it in decreasing order. So this will be x squared minus 12x plus 40. Okay, so now the question is let's see here. Is it factorable anyway? Nope, it's not factorable. So let's go back. I'm just trying something. So let's go back to that. So that didn't work. So let's go back to this. Okay, so that didn't work to simplify it. So let's leave it at this. And so now what I'm going to do is, at this point, I'm going to take the derivative of this. Okay, oh, and I'm going to rewrite this just to, again, because I'm going to have to use a chain rule here. So let's just write this to the 1/2 power. Okay, so if I want to find the derivative with respect to x, okay, so what am I going to get? Well, this here is just going to give me 1/8 because this is the same as 1/8 times x. So this is just going to give me 1/8 plus, now this, I'm going to drop the 1/2, right? So this is going to be 1/3, right? So I'm going to pull the 1/3 out because it's just constant. And then I'm going to say, okay, times 1/2. And now I'm going to do the derivative, I'm doing the derivative of the outside. So that's going to give me 4 plus the quantity 6 minus x squared, oops, to the negative 1/2 power, times the derivative of the inside, which is just going to give me, what? 2 times, well, which is going to give me a chain rule again, so it's going to be 2 times 6 minus x, and then times the derivative of the inside, which is negative 1. So it's going to give me a negative here in front of the 2. Okay, so now what does this give me? This gives me 1/8 plus, well, this is going to give me negative 2 times 1/2, which is going to give me negative 1. So it's going to be negative 1/3. So this is going to be minus 1/3. And then I'm going to get, in the numerator, I'm going to get 6 minus x. And then this is going to go in the denominator. So this is going to give me 4 plus 6 minus x quantity squared to the negative, positive 1/2 power. Okay, so now what I'm going to do is I'm going to make this into a square root. So it's going to be 3 times the square root of that. Okay, so that's what I end up getting. Okay, so now we want to set this equal to 0, right? Because I want to find all the critical values. Well, if I set that equal to 0, then what do I get? Well, I'm going to solve for x. So what I'm going to do is I'm going to add this to both sides. And so what do I get? Well, let me go back up here. Do I need any of this? No, I don't. No, I don't. Not right now. Okay, so now I'm going to solve for this. So this is going to give me 6 minus x over 3 times the square root of 4 plus 6 minus x quantity squared is equal to 1/8. Okay, now if I flip both of these, oh wait, do I want to do that? Okay, if I multiply, let's just multiply both sides. Let me multiply both sides. And so what I'm going to get is 6 minus x is equal to 1/8, so 3/8, times the square root of 4 plus 6 minus x quantity squared. Okay? And now if I square both sides, what do I get? Well, I'm going to get this squared, which is going to give me 36 minus 12x plus x squared, which is going to equal 9/64 times 4 plus 6 minus x quantity squared. Do I want to do that? So I got this 6 minus x here, and I've got a 6 minus x here. You know what, hold on a second. Because I see something here. Let's just square this and let's see what happens. Let's just do that, because I got this and this here. Let's just see what happens here. So this is going to give me 6 minus x quantity squared, which is then, if I distribute this, is going to give me what? 64 is divisible by 4. So that's going to give me 16. So that's going to give me 9/16 plus this, and then this reduces because this is, hold on a second. No, it's not. Never mind. So this is going to give me 9/64 times that. Okay, now we're getting close. So let's subtract this from both sides. If I subtract this from both sides, I get what? I get 55/64. 6 minus x squared is equal to 9/16, right? Because I can look at this as 64 over 64, right? I can just multiply by 1, right? So if I subtract 9/64, then I get 55/64 times this equals this. And then if I multiply both sides by the reciprocal, I get 6 minus x squared equals 9/16 times 64 over 55, which then this divides this, which will give me 4. Which then gives me 36 over 55, right? I believe that's right. And now I'm going to take the square root of both sides, and I get 6 minus x equals plus or minus the square root of 36 over 55. And so then x, well then x is going to equal 6 plus or minus the square root of 36 over 55, which is then going to be equal to 6 plus or minus 6 over the square root of 55. And that's the answer. Now, just like before, we have to consider both of these as far as the domain. Remember, the domain is from 0 to 6 miles. Well, obviously, 6 plus some positive number is going to be outside the domain. So, that means that the x is equal to 6 minus 6 over the square root of 55, and this is in miles. Okay? And so that is where he would have to jump in and start swimming to the island. Okay? That's the critical point. Okay? Now, we have to also compare the values at the endpoints, right? Because again, remember, we're going from 0 to 6 miles, right? So, we have to compare at the endpoints. Remember, the maximum value, or excuse me, in this case, the minimum value is going to happen at the critical point or at the endpoints. So if we stick in 0, right? So we go back to the original equation, and we plug in 0, and if we plug in 0, so t of 0 is going to give us approximately 2.108 hours. T of 6 is going to give us approximately 1.417 hours. Oops. Okay, now at the critical point, right, so if we do the critical point, let's do it down here, t of 6 minus 6 over the square root of 55, if we stick that into our formula for time, we get approximately 1.368 hours. And so, the amount of time it takes to get to the island is minimized at the critical point. Okay? So again, remember, you always got to check the endpoints because it could happen on a closed interval. Always check the endpoints on a closed interval. Okay, that's it. Have a great day.